Alright everyone, this is the next installment of the video. In this video we're going to be starting to perform the actual route procedure. And we're going to start with the tower planes. Now originally I thought this is going to be a sort of near the end concept, as we would use the power planes to consolidate traces. But when I thought about it again, I thought that we might as well start with them because the fact that we're orienting around high power. We can afford to snake these traces around, but these have to remain very direct. Now, the most intuitive one to start would be the ground, which is this set of traces right here. We're going to start with the top layer. Now, to start placing a power plane, what you're going to do is, you might as well zoom in a little bit as well. You're going to start by selecting the polygon tool right down here, clicking it, and basically just drawing pretty lines. That's in many ways what it amounts to be. And because we're handling high currents, what you should do is you should draw the plane much bigger than it actually needs to be. You're going to rename that to the 0-volt ground. And then you're going to click this rat's nest button or calculate the shortest air wire. You're going to see it seal up and actually create the polygon pour. Now what this means is this is going to be a solid area copper on our PCB. This isn't going to be a small wire. This is going to be a solid area. You'll notice these wires right here. These are called thermals. What it means is that the conduction of heat through these thermals are going to be much less than if it were just a solid pour. This is going to make soldering the part much easier. Now, of course, you don't really have to worry about tombstoning or any other sort of effects that occur. We're going to be using a through hole with a soldering iron, so I'm not too worried about too much heat conduction, so I just turn thermals off. Then what you're going to do is you're going to use the show objects tool, and you're going to show all the grounds. Now, these right here, these are our high current connections for the gate drivers. These are what we're going to worry about connecting to. All of these on this side, if you remember from the schematic, these are our no connects. We just happen to connect these to ground to be safe, to make sure we're not floating, especially because we're dealing with an opto-isolator. So if the voltages were floating, that could present possibly an issue. That being said, these can just be traces, but these pins right here have to be padded out. They have to be ground planed. So here's what you're going to do. You're then going to enable diagonal routing, and then you're simply going to take a pattern like this. You're going to connect that. You're going to bring a nice wide strip down. And there's one section of the ground plane. Then obviously you're going to rename it using the name tool. 0-volt. You're going to make sure thermals are off. And then you're going to consolidate it. And there's most of the connections already made for you. There you go. The next step is to finalize the connection. So what we're going to do is we're going to connect all these kind of leftover traces. Using smaller polygons. Once again, turn thermals off. And then rename them. And then it gives me this. And I'm pretty sure where the fuck up is right in here. So I'm going to do that. And we attempt to consolidate them, and it works. And we might as well go ahead and connect the shorter signal grounds in. Sometimes Eagle makes a little bit of a fuss about this, such as telling me it has to be connected even within a ground plane. Does it really have to be? No. So there's most of the connections mapped. And now it's time to do the actual voltage rail for the gate drivers. Basically, same process. Come here, click. The connectors don't exactly have much tolerance to them, so you're going to want to kind of build that in when working with traces. I'm also going to make it one solid slab. Rather than mucking with multiple planes. This is the kind of thing that you want to get the hang of, because it doesn't matter what you're doing, you're going to want to use power planes. Whether you're constructing simple high power boards, or or whether you're working with FPGAs, for example, you're going to be using power planes a lot. It's a necessary skill to have. Obviously, again, turn thermals off. Fuck them. I'm not gonna lie, that looks good. Now, obviously, do the other do the exact same thing with the other side, you have to remember the other side is reflected, so the geometry is not going to be perfectly symmetrical. So we might as well now add the gate drive in. What we're going to do is we're going to put the gate drive across the bottom, not the top, to improve the isolation. You'll also notice that because of the fact that the spacing on the gate drivers is slightly different from the spacing on the IGBTs, because of the fact that they are different sizes, and due to the fact of how we place them, each one of these different pores will have a slightly different shape to it. That's not much of a worry at this point. You're also going to want to extend the contact area out just a little bit on these IGBTs, just to give yourself maximum current carrying capability. And now if I know these connections right, actually I didn't name them anything specific. So we're going to want to use the show objects tool. You're going to want to name them as the connection is actually named. This is going to, because if you don't, Eagle will then throw a mess at you later on when you try and consolidate them. It'll basically have this wire cutting through, because as far as Eagle will be concerned, this wire will not be that actual connection. So we have 3 and 5 from there. Actually, 26, 29. And now consolidate them all, and you'll see those connections map out. So as you can see, we already have, for most part, one entire bank done as far as power considerations, or at least in the sense of the gate drivers. Then what we do is we add the IGBT supplies in, basically exact same concept, and from there we're mostly done. Then we just do some trace routing here, although this can be done with an auto router. This does not require any special skill. Alright, well that being said, that's going to do it for this video. I'm going to go do some stuff to this board in the meantime. We'll pick up once more of the board is done. Again, all the stuff here is intuitive. You just simply have to learn how to do it. At this state, I mean, if you're watching this video because you need to learn something, then at that point, you do just have to practice it. There really are no ways around that one. Alright, well, see you guys in the next video.